Yo, works, click, works. So what it does is you can drive around, right? So forward and backward, and you can rotate left and right, and it's actually drawing 1,000,000 data points. So now inside this plot there are actually 4 lines of 1,000,000 data points being plotted. And with these two you can zoom out and you can zoom in. So notice the axes are right now in the order of magnitude of the power of 1, 10, 3, and as you progress you can zoom out extremely, so it becomes like a fractal. You can plot lines across magnitudes, orders of magnitudes. It's like crossing into other dimensions in space. And bear in mind that right now there are more than 2 lines of 1,000,000 data points being plotted. The thing is, when you zoom out, it always ends up being in 1 pixel. So it actually plots pretty damn well. And I'm thinking how to make this into a video game. I mean, it's fun to see how 10 to the power 13 can be drawn. And it does feel like you're gliding out into space. And you can see the previous history of drawings you have made. And I'm thinking, how do you make this into some kind of a game concept? I mean, it's pretty cool that you can save all of this history, but how would you make it into something to explore? Notice the 0 is made as a dot. And now there's another dot, another universe, if you say so, around here. So if I start zooming in, and now zooming in towards something is actually more complicated than zooming out. But again, this fractal nature, this is not where we started, this is a different universe. And I'm zooming into it, power of 15. I can still try to get closer to it. Yeah, zoom in. And it seems like those lines are crossing those bubbles, but are they? Are they really? Let's see, let's zoom in, zoom in, zoom in. Yeah. Is there anything here to see? And now you can see that this dot is actually not a dot. There are 2 dots. And here is a dead explorer from the previous exploration. Huh. And if I keep zooming in, you can see 2 distinctly different points. From far away, this empty circle and this filling, this star, they look like 1 dot. But now if we zoom in closer, you can start to see edges on the circles and all kind of data points that come from being far away. And if I keep zooming in at this point, it will eventually crash because off-center, one axis is not able to scale as the other one is. And this is to the power of 19 now, plotting, and this is power of 8 because it's sensitive to how far away from 0 you are. You cannot zoom in so much. If you are further from the 0, the floating points collapse. So this really shows how huge the space of floating points really is, how much information you can fit with these floating point numbers. I think it's a valuable academic exercise to have one thing is to exercise plotting skills, animating the numbers, because math is for drawing pictures. That's all the math does. Math is only for describing pictures. Drawing lines, fitting curves, it's all drawing. It's a pencil that you write code for. Mathematics is a language of capturing proportion. And code is for capturing logic. So you can change that proportion based on logic. And these commands are logic gates technically. So I think that's a powerful tool to illustrate how easy it really is to create your own universe, numerical universe, floating points. And then you can make a spaceship, fly around it with minimal inputs. Just zoom in, zoom out, move left, move right, and you can fly around across this orders of magnitude in a single plot. Let's see what happens when you move. And moving away from a point is so easy. No matter which direction you go to, it always converges. It's like running away is easy. But if you try to chase a point, suddenly steering becomes much harder. And as we move out, we can see what was there before. So it's kind of familiar. It gives you memories of what you were doing. And it's a fractal. It really is a fractal. You're creating your own fractals. And there you go. That's beyond the horizon of no one has been here before. It's a completely new landscape. And now all of those structures and drawings and pictures, they're still inside that dot there. But they are so tiny now. It's 1 pixel. So really, this is a type of fractal. I don't know if there's a name for this kind of fractal. It would be interesting if someone knows the name of such fractals made by input history. And I mean, mathematically, this would be hard to describe because there's so much random logical inputs. Every push of a button is a logic gate, and there's no predefined rhythm to it. So it's a non-repetitive fractal. It's kind of a random, completely randomized fractal path. And power of 53. And there is no more universes in this game so far. I could put more, and then if you find a new universe, you could zoom into it and find some maybe pictures or some secret codes or whatnot. But the size of these numbers is pretty much unlimited. If you zoom out, you can go to the power of 10 to the power of hundreds, I suppose. And if we zoom back inside, you can see again this traveling towards the center of the galaxy, back towards the center of the fractal. And it's quite crazy that this line has 1 million data points, which are being just technically fed backwards. I made it so that the whole 1 million points is shifted 1 point back. So it's not growing, it's just a constant length. And maybe that's not a very efficient way of starting it. Maybe it should be filled up gradually and so forth, but I kept it simple. And Matlab seems to be handling it pretty well. And yeah, let's see. You'd be surprised how entertaining this is. So I highly encourage you to try and code this thing yourself. Buy a joystick and start coding with animated plots. Explore your data and measurements with a joystick. Super entertaining. Let's see if I can go back to the universe. Here we go. That's the first universe. Event horizon. Or whatnot. Make your own names. This is not something I'm copying. This is something I invented. I don't know if it already has a name or not. And this is a funny situation. You cross a point and then you start zooming in. You can actually stand while zooming in. And then suddenly the line is actually not crossing that dot that you thought you were crossing. Magnificent. I would imagine something like this would be a pretty good music video. Too bad I'm really bad at making music. And here we are back to seeing both universes. So in this universe, there are 2 points which will split apart, and the 0 allows you to go much, much closer to zoom in. So there is a trade-off that off the 0 axis, you cannot really make it, you cannot zoom in so close. There seems to be no limit to how close you can zoom in towards 0 without ever actually reaching the 0. But there is a limit on how close you can zoom into something offset, which is again a good lecture content about what floating point limitations are, how the binary is distributed within variables. It's crazy. Every time you do this, you end up with something unique. Technically, it's almost impossible to repeat your own previous steps. So each time you close it and you plot something on top, you create something completely new and unique. Here is a dead traveler from the last time. I think it died before even starting, so we can just go past it. Fascinating. Let's see, is there anything deeper down here? It seems like there has been movement before. Uh-huh. 10 to the power 4 minus 5. Seven. 8 minus 9. Minus 10. And I think there will be no limit to how close we can zoom in. So when the line starts drawing from the 0 position at the very beginning, it's kind of like cheating. Though there is a chance that it wasn't perfect. Maybe there is a way to zoom in beyond the actual floating point. But it seems no traveler so far has been here, in this simulation at least. Oh, there we go. We have reached a point where the lines are unstable and they disappear. Pow! And there we go. That was the floating point limit of the original zero. And now we are in the submicroscopic space where no one has been yet. And I can stop zooming in, I can make some drawings. I can cross the zero a few times just to make it more interesting and see how close did we get to actually crossing the zero. Start zooming in, and again, it's a fractal pattern. We are zooming in forever. Down to the minus 50. Now, let's go back one more time.
Let's see.